Hello and welcome to this section of the MATLAB tutor. Here in this section we're going to apply some built-in functions that MATLAB has to matrices to learn a little bit more about them. So specifically we'll be using the size operator and the length and min and max and things like that to learn more about matrices. And also keep in mind we've done most of these functions and applied them to vectors already, so this is sort of a natural extension of what we've already done. So what we have here is, let's go ahead and create a matrix. We'll call it matrix 1. And let's go ahead and just put some elements in there. This could be anything, but let's say 3, 4, 5, 2. And then for the next row, we'll 1, 1, 1, 1. And for the next row, we'll do -1, 0, 2, -3. And I think that's going to probably do it for what we need. So let's go ahead and define that matrix right there. So here we have a matrix. We have 3 rows and we have 4 columns, right? All right, so the first thing is we have this guy defined here. What is going to happen if we use the command size? There is a command in MATLAB called size, and you can apply it to vectors and matrices. So let's apply it to this matrix here. Matrix 1, what do you think it's going to come back with? Well, MATLAB's going to tell you it has 3 rows and 4 columns. So that's exactly what we have here. So notice MATLAB returned 2 numbers, but more than that, MATLAB returned a vector. I'm trying to point out to you the way MATLAB works is when it needs to return more than one value for anything, usually it arranges it in the form of a vector. Anytime you see the numbers spaced apart horizontally like that, that's an internal representation of a vector. In fact, you can see the last answer over here, bracket 3, 4. That is the representation of a vector. If I had just created one, that's exactly what it would look like. So MATLAB's coming back and saying, okay, there's 2 relevant numbers here. One of them's 3, one of them's 4, and that's the size. So you don't get one number back. You just get the dimensions, basically. And that's useful actually, because even though we type this matrix in, you might have a situation where you need to kind of expand your mind. I mean, yeah, we can see 3 rows and 4 columns here. But if you have data that you're importing into MATLAB, large data sets, you may not know ahead of time how many elements are in the rows and the columns. So if you import everything in, then this might be something that you might write into your MATLAB program to tell you how large it is. All right. Another relevant command to this guy would be length. And we used length when we applied it to vectors. You can see MATLAB's telling you to stick an argument in there for an array. So we'll just put this matrix in here for length. What do you think that's going to put? So we'll put that answer in and you get a 4. And you scratch your head a little bit and you're like, how is the length of this 4? Right? Well, what's happening here is the size of the matrix was returned as 3 rows and 4 columns. The length of a matrix is always going to be the larger of these 2 numbers. So if this were 3 rows and 5 columns, it would return a 5. If this were 16 rows and 2 columns, it would return 16. So whichever one is the largest value of the rows and the columns, of the dimensions of the matrix, is what it's going to return for length. And we've already applied this length operator to vectors, and that just gives you the number of elements in the vector. But when you have 2 dimensions, MATLAB has to choose what to tell you the length of the thing is, and it's just going to pick the largest number. Is that very useful for you? Not sure, but it could be useful if you're importing large data sets. Now this is, I think, a little more useful. Number of elements. NumL, like that. Number of elements, that's what that stands for. And you can pass it matrix. Well, look at that. I didn't define the matrix properly. Matrix 1, that's the name of our matrix. 12. And this is exactly what you would think it is. It's the number of elements contained in this matrix. So in other words, we have 3 rows and 4 columns. So we all know from multiplication, 3 times 4 is 12. There's 12 elements in this matrix. So MATLAB is calculating that for you. And in fact, that is useful as well. Again, if you're pulling in a large data set from some survey or some experiment, you might need to know what is the size of the matrix, how many elements are in the matrix. You might use that in your program. So these are built-in functions MATLAB has. Let me go ahead and clear the screen. Put matrix 1, let me go ahead and clear the screen again. Put matrix 1 back on the screen. And let's do another one. We'll call sum. And we used this in a couple sections ago. I illustrated this for you, but I'm going to show you one more time. When you apply the sum operator to a vector, just a regular old vector, which is a list of numbers, MATLAB adds up everything in that vector and gives you the answer. When you apply the sum to a matrix, what MATLAB does is it adds up the columns. So when you sum these three things together, the 3, the 1, and the -1, you get 3. 4 plus 1 is 5. 5 plus 1 plus 2 is 8, and so on. So it's summing up the columns, right? And that's what it's giving you whenever you apply the sum operator to a matrix, because it's not going to default to adding every element up. It defaults to adding all the columns together. If you want to really add up everything in the matrix, then you can just do it twice. And what happens is the inner guy gets evaluated first, and this is going to produce this little vector of numbers, which is the sum of all the columns. And then when you apply the sum to this vector that this returns, it adds up everything. It basically adds up all of these numbers. And so when you do that, you get 16. So when you add all of these things together, all of these elements, you get a number of 16. All right. Let me clear the screen and put the matrix back on the screen one more time. And I'm going to show you a couple of functions that we use back with vectors and show you kind of how they behave with matrices. We showed you how to use the min function. In vectors, like if you just had a listing of numbers, a vector, then when you find the min, it's just going to give you the lowest value, the least value of all of the values in your vector. When you apply it to a matrix, it doesn't give you the smallest value of everything here. It does it column by column. So it looks in column 1 and it says the smallest value is -1. Column 2, the smallest value is 0. Column 3, the smallest value is 1, and so on. Smallest value here is -3. So when you apply some of these things that work intuitively to vectors, when you apply them to matrices, MATLAB in general likes to work column by column to give you that. And the same thing happens if you use the max function. When you want to find the maximum value of whatever is enclosed in your matrix, it goes column by column. Here's 3, here's 4, here's 5, here's 2. All right. Now, if you really wanted to know, let me clear the, well, I'll leave it up here. If you really wanted to know what is the minimum value in your entire matrix, then you can just do it twice. Min, matrix 1. Make sure you understand that. What's happening here is first MATLAB goes in the middle. It evaluates min of matrix 1. You basically get this vector back, and then it applies the min function again to what you get back. And you can see the smallest value here is -3. And so you get -3. So this is the smallest value of the entire matrix. So if you have a matrix of some survey respondents with 1,000 people or something like that, then you could easily find the minimum value without pouring through a spreadsheet or whatever. And you can do the same thing with max. Just apply it twice, and the maximum number contained in this matrix as far as elements go is 5. So that's really all I wanted to show you in this section, just some general little functions to learn more about the matrix, to probe it. You can find the size of the matrix, which is basically the dimensions, the length of the matrix, which is basically which is the largest dimension, the number of elements it can calculate for you, the sum of the elements, and how to find the minimum and the maximum values of what's contained in your matrix. So when you're typing in small matrices like this, it's not necessarily helpful, but you also have to consider that even if it's a small matrix, I'm teaching you all this as far as fundamentals in terms of, okay, we're typing in matrix 1, here is what it is, and then we're applying some stuff to it. But you might consider that you might have even if you don't talk about importing data, you might have a function or a .m file that we'll learn how to create later that's going to go off and you might have some input values and it's doing a long calculation, some simulation or something, and the result of the simulation is a matrix. The matrix might only have 12 or 16 elements. It might not be huge, but the point is the matrix is going to be calculated each time you run the program, so it's going to be a little different. So you might have a need to calculate this matrix and then pull the maximum value out of it. Or to pull the minimum value out of that matrix automatically and display that on the screen. And each time you do the calculation, you might get a different matrix for an answer, and so a different minimum value or a different maximum value. So some of these functions that seem a little bit hokey, they just seem hokey because we're typing the matrix in. But you need to think about, okay, what happens if I'm running a program that's calculating a matrix answer? And then I want to pull values out of that, or I want to learn about what the maximums are or whatever. So these functions are built into MATLAB. So make sure you know how to use them and play around with them. They're real simple to use, and you'll see exactly how MATLAB is trying to work here.